discussed about how the equilibrium EMF series can be calculated by using this table followings. Whether the elements which are produced as a hydrogen and the H2 electron, which is used as a reference electrode, and above the elements which are all present as the anodic, and below the hydrogen electrode, the elements which are also considered as a cathodic protections. And we have also seen how the elements can be calculated by the EMF, that is E is equal to E right minus EF, and the displacement of one elements and oxidation of reduction process. Now we are going to see about, by using this same elements with these elements, we are going to identify this equilibrium constant, the K for the reactions, which is considered as a K value, that is from the Nernst equation. We also consider that del G equal to NEF, that del G equal to minus del G not equal to RT ln K, and which is considered from this Nernst equation, and we also substitute this from the del G, that is 2.303 RT log K. So from this equation we can consider this, and the log K we also know log K equal to minus del G naught divided by, from the value of RT, 2.303 RT. From this we are considering the del G equal to NEF. So from this first equation we already know del G equal to NEF. So del G naught is also considered as a NF E naught divided by 2.303 RT. So from this the values can be calculated for the K value of equilibrium constant from the values of hydrogen as a reference electrode from 0.00 voltages to this elements of the lithium, magnesium, aluminum, zinc, Fe2 plus, lead and hydrogen. With this below elements of the copper, Ag plus, Pg and Au, half electrons of the fluorine, which is considered as a cathodic, and the anodic properties, which shows a higher tendency toward this equilibrium constant from this values. And the next point is hydrogen displacement between these two elements. So whenever the hydrogen is called as a reference electrode, which is considered as arbitrarily fixed as 0, so that is we are using this hydrogen as a reference electrode. From this, the replacement of a hydrogen below above the anodic properties and below the cathodic properties, we can consider some more features from this. So from this Li plus H, we can use no reaction. We can also not consider the reaction. And Mg2 plus H, we are also not considered with this acid groups, that is H group, and Al3 plus also, which is not combined with this H group. Zinc plus H, so zinc when react with this sulfuric acid, that is Zn plus H2SO4, which react, zinc will react with the sulfur SO4 and the hydrogen equations, so which gives the E0 zinc value of 0.76 voltages. So when only the hydrogen can displace by using this only with the zinc, and below the cathodic properties of Cu2 plus, it cannot be react, and same as the Ag plus also, which cannot. The Ag plus same the reactions will follow from the sulfuric acid. Ag plus H2SO4 will reacts with AgSO4 will not react, so it forms as a no reaction products, and it gives the EMF of the voltages of E0 Ag equal to plus 0.80 volts. So from this we can identify how the elements can be displacement from the one element to the other element by using this reference electrode of the hydrogen. So from the hydrogen has, because the hydrogen has an electron volt of 0, which has considered as a standard hydrogen electrode, and the last one is a predicting spontaneity of the redox reactions. So when both the reactions can be occurring by using this redox, whether it is oxidation or reduction process, the reactions will be the spontaneous or feasible reactions. For this we can consider the examples of when the elements of the anodic process, it should have E0 cell is in the negative values, the reaction it is not in the feasible properties, because the reaction will not consider and it is a feasible. Whether the E0 cell is a positive reactions because of this elements, we can take it as a spontaneity reactions. The spontaneity is nothing but the reactions will be a throughout following the reactions which consider the reduction or the production process. Oxidation can be occurred by using these elements, and whenever the spontaneity occurs during this reference or electrode by using this anode and the cathode, the reactions follows throughout this by predicting whether the E cell equal to E right or E left. So this is the application behavior of the EMF series. Thank you.